Hello everyone, we are BlueFarm, Intelligence Beneath the Surface, and our team ID is 1572. We are a student-led team working at the intersection of aquaculture and technology. Our goal is to support small and medium fish farmers by making water quality monitoring systems smarter, simpler, and more affordable. BlueFarm is not just a project for us, it is an effort to bring accessible technology to a sector that feeds the nation yet lacks timely support. Aquaculture plays a vital role in India by supporting food security, livelihoods, and economic growth by the farming of fish and shrimp. India is the second largest aquaculture producer globally, and fish production has more than doubled in the last decade. Despite all of this, fish farming is often overlooked when we talk about agriculture, and our aim is to change that very mindset by giving it the recognition and technological support it deserves. This is the statistics of India on a global level in regards to fish farming. As we have said earlier, India is the second largest producer, with China the first and Vietnam the third, followed by Indonesia and other countries who does fish farming. Fish farming in India is a major source of pride and survival for millions of families. For states like Andhra Pradesh who lead the sector, with West Bengal, Odisha, Kerala and Assam who are also heavily dependent on fisheries. However, the manual and costly water testing often results in disease outbreaks and financial losses. With over 28 million livelihoods at stake, which tells us that effective water management is absolutely critical, and that's where we come in, bringing a device for the farmers facing this very issue. This is the Indian statistics state-wise for fish farming. On the left-hand side, we see state-wise contribution to India's aquaculture. Andhra Pradesh leads with West Bengal in tow, Odisha, Gujarat, Tamil Nadu, Kerala, and Assam. On the right, we see the statistics of profit and loss that each state has made with fish farming. Next, we have is market analysis. We have done market analysis of India's aquaculture sector, which is worth over 1.24 lakh crore and it is growing rapidly. Yet most small-scale farmers remain underdeserved. Nearly 70% of farmers still depend on manual testing, which leads to losses from poor water quality, disease, and climate uncertainty. While some solutions do exist in the market, but they either cater to large farms or focus only on shrimp and marine sectors, or just offer basic monitoring systems without any intelligence. And that's where BlueFarm comes in. BlueFarm addresses this gap as a low-cost, modular solution for freshwater fish farms, combining real-time monitoring with AI-based prediction, which we are hoping to bring in the future. We have done a literature survey. We have read few papers in regards to the fish farming IoT devices to gain our knowledge and know about the present situation of fish farming. And here are few papers displayed for you with a short brief about it. We have gathered details about the three most cultivated fishes in India, which are rohu, katla, and mrigal. These are the details that we have gathered about the katla fish, which is a freshwater fish. So katla is a surface feeder and has a lifespan of 8 to 10 years, and it can grow up to 1.5 meter, which is 45 kgs. We have this is a major fish farming choice in Andhra Pradesh, West Bengal, Odisha, Bihar, Uttar Pradesh, Chhattisgarh, and Assam. We have gathered information of its feeding, of its growth rate, breeding details, and we have even gathered information of what the water parameter should be like when it is in breeding phase, when it is should be in normal growth phase, and harvesting phase. And we have done the same for all three fishes. Now the problem statement. Right now, the most fish farmers don't have access to real-time water quality monitoring. The only data they get is when they manually test the water themselves, which means problems are often detected too late. Sudden changes in pH, temperature, or oxygen level can go unnoticed for hours or even for days. By the time the fish shows some stress or disease, farmers may already lose up to 20 to 30% of their stocks in a single cycle. Even when some monitoring tools exist, they usually just show numbers without explaining what action to take, which is why farmers need a simple system and that monitors continuously and sends alerts and guides timely decisions. So our solution to this problem is a smart, low-cost system that continuously monitors water quality in a real time. We place sensors directly in the pond to measure parameters like pH, temperature, ammonia, dissolved oxygen, and turbidity. This data is sent through a microcontroller, which is further sent to an app, a mobile application. On the app, farmers can see live readings, past trends, and safe ranges so they can immediately know if something is going wrong. If any parameter crosses its limit, the system sends an instant alert along with suggestions on what actions to take. Instead of depending on manual testing, this allows early detection of problems, reduces disease risk and fish mortality, and cuts down the need for lab testing, which is expensive for small scale or medium scale farmers. This app also provides weekly and monthly reports to help farmers track their farm's performance over time.
This slide represents the technical stack of our smart fish system, which includes both the hardware and components used in the physical setup and the software technologies used for automation, communication, and data analysis. On the hardware side, our main controller is ESP32, which manages all the three sensors and modules. We are using water quality sensors such as pH sensor, dissolved oxygen sensor, temperature sensor, turbidity sensor, and ammonia sensor. To continuously monitor the pond health, we also have automation components like submersible pump for water circulation, a fish feeder motor, and an aerator motor to maintain oxygen levels. All these devices are controlled through a relay module, and ESP32's inbuilt Wi-Fi enables real-time data transfer to our digital program. Additional components like camera module and proper power regulation circuits help enhance monitoring system stability. On the software side, we program the system using Arduino IDE with languages such as C and C++ for monitoring and controlling the system remotely. We use IoT platforms like Blink, Firebase, and ThinkSpeak, which allow us to build a mobile app and web dashboard for live data visualization. We also integrated technologies like MQTT protocol for efficient network communication, and future versions may include machine learning, sensor flow, and CV for automated fish health analysis and smart predictions. Overall, this technical stack allows our system to connect the physical and fish farm environment with digital world, enabling smart monitoring system, automation, and decision making for improved fish farming efficiency.
Progress of BlueFarm. On the hardware side, we initially started with Arduino Uno to interface and validate the pH, turbidity, and temperature sensors. This helped us stabilize the readings and verify accurate data acquisition through the Arduino IDE. After successfully validating the sensors, we transitioned from Arduino IDE to ESP32, which allows built-in Wi-Fi and supports real-time IoT communication. We connected the ESP32 with the Blink platform to display live sensor data. While this integration is functional, it requires further polishing and optimization. Because of this, we are demonstrating the system flow and user interaction using a lovable based dashboard, which serves as a clean proof of concept of how farmers will use this application. At the same time, we are also actively exploring and refining multiple app and cloud options to build a more scalable and robust final solution. So, we have built a demo app using the Lovable platform. So, we have built a demo app using the Lovable platform to show how farmers will actually use our system. The app basically acts as a link between the farmer and the pond. showing real-time water quality data in a very simple dashboard. The farmers can quickly check things like pH, temperature, turbidity, ammonia, and dissolved oxygen, and they can look at weekly and monthly data to understand how their farm is doing. And if something does go wrong, the app sends alerts and suggests what action can be taken. Apart from that, we have added a farmer profile section where it has information about nearby diseases with symptoms and preventive measures, current fish price trends, and nearby markets where the farmers can sell their fish, including distance and approximate prices. It also shows past trends in that pond. The idea is to make the app feel less technical and more like a daily support tool for the farmer. Currently in the video,
My name is Manas Pandey, and today I'm going to introduce you to our product Fish Farm, where we use ESP32 module for basic programming, which is connected to the three sensors: pH sensor, turbidity sensor, and temperature sensor, which give their respective values to the ESP, which then come to the program where we use Arduino IDE for the code, which then transfers the output to the digital software Blink, where we get the respective values of pH, turbidity, and temperature. We also get the graph of pH and temperature with the with same as turbidity. This slide represents the business model canvas for BlueFarm, which explains a smart fishing farming solution works as a business. Our key partners include hardware and sensor supplies, IoT devices such as ESP32 vendors, cloud service providers such as AWS or Blink, and government fisheries department that help with implementation and awareness. The key activities focus on designing and developing IoT systems, integrating sensors, automating feeder and irrigation, and providing data driven monitoring with the ongoing support and training for farmers. For value proposition, we provide real time monitoring of water quality, automated fishes and fish care, and early warnings that help farmers prevent fish deaths. This leads to higher yields, reduces loss, lower manual effort, and optimized resource usage for institutions and industries. We provide data driven insights for large scale fish farming. Our customer relationships are based on personal assistance, training workshops, regular maintenance, and subscription based service support. We reach customers through direct sales, government schemes, online dashboard, and through fisheries training centers. Our customer segment includes small and medium fish farmer hatcheries, aquaculture companies, NGOs in rural development, and export focused producers. The cost the cost structure mainly includes hardware and sensor cost, cloud and software development, logistics, maintenance, and R&D expenses. Finally, our revenue streams come from selling IoT hardware kits, subscriptions for cloud monitoring, maintenance services, and custom solutions for large agriculture firms. This business model aims to make fish farming smarter, more affordable, and more profitable.
future plan for BlueFarm. So in the next phase, we are planning to add dissolved oxygen and ammonia sensors to make the water quality monitoring system more complete. And after that, we'll introduce AI-based features to help with breeding stage analysis and to predict right time for harvesting. By combining sensor data with fish behavior patterns and the system, we will be able to detect early signs of diseases. This means the app can warn farmers in advance and suggest preventive actions before the problem spreads further. Overall, these improvements aim to reduce fish mortality, minimize production losses, and lower financial risk for the fish farmers.